Okay, going back to slide 57, where we left off last time, speaking about HACCP. Again, this is the first of 15-minute videos. We'll pick back up here as far as on the HACCP plan, pork sausage. We go through and we recognize again, like say, person responsible is being named in this, monitoring procedure and frequency is being named in this step. So these are important parts of the HACCP thing. And we'll go through and we'll see this later on as we go through that someone has to be named a responsible party. And as much as you may not like it, you've got to be able to go through and point a finger at someone. Corrective action. What do we do once we find that something is wrong? Once we realize that something has gotten out of compliance, we have deviated from where we need to be, something has to be done to fix it, and that is a corrective action. Move to an acceptable area and destroy spoilage. Fix a cooling problem. If we're not reaching that 39 degrees Fahrenheit or less, fix that cooling problem. And who's it going to be monitored by? The unit manager, somebody responsible. How do you go through and monitor it? You're going to go through and have those storage cooler temperature logs that you're going to go through and you're going to have as far as those records. And then how often or who is going to go through and verify that you're doing what you're going to go through and do. A secretary. It doesn't have to be somebody that's scientifically minded. We do want that. That would be preferred. But we can go through and we can do it with a secretary just to go through and make sure that these people that actually know what they're supposed to be doing is going through and doing their job. QA shift employee will verify thermometers daily. See, we can't have the person that's verifying logs going through and verifying the thermometers because this person may not have the complexity of education to go through and understand how to truly verify those thermometers. A couple things we got to go through and think about. CCPs and control measures. So what are CCPs and how do we define them? Critical control point is any point in procedure in a food system where loss of control may result in an unacceptable health risk. How do we control them? We implement those preventative measures to reduce the risk that a CCP could occur. Preemptive. Remember, HACCP is not a reactionary process. It is something to go through and reduce risk before it ever occurs. It does not respond. It tries to prevent. We execute corrective actions. Those are things once we do see that there's a problem, we already have to have those planned out, right? When you came to college, what did you have as a secondary option if you didn't get into college? So now it's one of those of, hey, what do you have as a secondary option if you don't pass college? What do you have as a secondary option if you don't get the job that you want? You know, those are corrective actions, and you need to go through and plan those things out. If the perfect thing doesn't happen, what is your backup? You need to be able to go through and identify critical control points. Examples of preventative measures for controlling some of those identified hazards. These are just examples. Maybe some various pathogens, Salmonella, E. coli. You have pasteurization. You try to prevent recontamination. One thing as far as a point of control, you may go through and have a pasteurization. And that may be truly listed as a critical control point. Now let's jump down here to metal fragments as far as a physical, right? These would be physical. If we went through and we had metal fragments, a physical hazard, we may go through and install magnets. We may go through and use that after each unit. If you're using it after each unit, it may just be a control point. And then if we go through and we have a metal detector, that would be after packaging. There's nothing else that's going to go through and catch it after packaging. Up here, something else may catch it. Down here, nothing else will catch it. That is a CCP. Control point, critical control point. Some examples of preventative measures, control parameters, and means of control. Growers. We want to go through and make sure that those growers are using approved pesticides and they're using them according to regulations. Control methods. We have a good working relationship with those growers, those field persons. We go through and we get letters of guarantee so that, again, if we have to, we can point a finger. If we go down here as far as the metal detector, hey, we know that we can't go through and have somebody just standing over it looking at it. We need something to actually go through and detect those small metal fragments. So we need to go through and figure out how large can those metal fragments be. And we may go through and set a size that the metal detector can detect And the only way that we can go through and have, proper control methods or proper how large those pieces of metal can be is to go through and recognize that we need regular calibration. Requirements for an operation to be considered as a critical control point. Operation must be such that appropriate action will prevent, that's what we're trying to do. We're trying to prevent something before it ever occurs. Control or at least minimize one or more hazards. Again, trying to stop it before it ever occurs. This is not reactionary. Number 2, severity and or risks of the situation must be considered as being high or at least moderate. If it's, the chance of it happening is very low, then we don't really need to go through and spend a ton of time and a ton of money to go through and try and reduce it, right? Number 3, criteria for control must be established. How do we control it? How can we control it? If there's no way to control it, then it's one of those to where you need to move to find out a way to be able to control it. Critical control point must be capable of being monitored. And that's one of the things when we go through and we look at assessment, going through and evaluating your grades. We need to be able to go through and know, how do we monitor your grades? How do we go through and look at your grades to go through and make sure that you're on track? Critical control point must be monitored either before startup and or during operations. It's best if you can go through and do both. But sometimes cleaning is, as a good example, will just be one of those things done before you start operating. 6, appropriate action must be taken when results of monitoring indicate that specified criteria have not been met. If you go through and you see that you're monitoring something and it's outside of compliance, then you need to go through and do something about it. Appropriate action must be taken. That's your corrective action. Microbiological limits. Procedures at these critical control points would be designated to destroy, eliminate, or reduce microbial contamination. You recognize that you've got problems as far as microbial growth. It didn't cook long enough. It didn't cook at a high enough temperature. You went through and you brought something into your plant that was unsafe to start with. There are several things that you can go through and recognize may cause problems. So what do you go through and do to destroy, eliminate, or reduce the potential for microbial contamination? One of the big things, just prevent it to start with. If you don't allow it to come into your plant, then hey, you're ahead of the game. The other thing is, once it is there, how do you inhibit growth and or toxin production? Things that you have to be concerned about as far as CCPs. Heat is lethal to microorganisms. And, I'm going to go off on a tangent here. It is one of those to go through and understand that depending upon the level of heat that you use, depending upon the food product that you have, if you heat it too much, you may actually go through and cause chemical concerns or chemical hazards that you're going to go through and you're going to develop within that food product. Heterocyclic amines is one of those, but that's something for a later class. Heat is lethal to microorganisms with each species of bacteria, each species of microorganism having its own particular heat tolerance. The rate of destruction is logarithmic. That's a factor of 10. During a thermal destruction, process depends upon the temperature and time. That's the reason we go through and we say that you cannot cook food or you should not cook food in a microwave because you cannot reach the time temperature requirement to go through and make sure that it's safe. Your starting concentration, your acceptable concentration, thermal resistance of target microorganisms. And that's kind of like when we go through and we look at blanching, for those of you that know about blanching. When we look at blanching, we want to go through and target the one that's most heat tolerant first. If we go after that one, the one that's most heat tolerant, we go after the one that's the biggest, the baddest, able to withstand the heat, able to withstand the temperature, able to withstand the pressure, able to withstand the time. If we go after that one, we know that we kill it, we know that we destroy it, we know that we will go through and take out all of the others because they will be weaker than that one that is the most heat tolerant. And the temperature-time relationship required for destruction of those target organisms. We can calculate that, and if we calculate that, we can know, hey, we've got to make sure that we reach these goals. Thermal death time, or TDT, studies are conducted to determine the heat resistance of microorganisms. Now, this is one of those where it needs to be done within each different product type. Again, if we go through and we've got a clear chicken broth versus a chicken broth with chunks in it, be it potatoes or chicken pieces or chicken and noodles, those are all going to go through and have different thermal death times because that those solids will cook and heat at a different rate than just the broth itself. TDT test is used to find breaking points or time between destruction and survival of the organism at each point of the different temperatures and calculate survivor curves. How many survived? How much of a problem will it be? The D value. Now, you need to go through and know these. Okay, there's going to be several terms that come along. TDT is one. D value, F value. You need to be able to go through and take notes on this. Okay, just point of information. The D value is defined as the time in minutes at a constant temperature necessary to destroy 90% or 1 log of the organism present. Now, that's the organism that you're targeting. Okay. During that heat treatment, a 90% reduction in microbial population occurs at a constant interval, regardless of the initial population. This 90% or this 1 log reduction is referred to as the D value, or the decimal reduction, or the logarithmic or log reduction. These are all meaning the same thing, but really and truly what you're looking at is destroying 90% or 1 log of the microorganism. The Z value is defined as the number of degrees between a 10-fold change or 1 log cycle, that 90%, in an organism's heat resistance. So the D value will be 1 log higher or lower when it is heated. Z is a value of how far you're heating or how long you're heating it as far as that temperature, right? Z is how much are you heating it. So you'll go through and you'll have a D value, a 1 log reduction when you heat it Z. If you go through and you recognize that it's 5 degrees Fahrenheit, to go through and have a 1 log reduction. If you heat it 5 degrees, then you heat it 10 degrees, you should be able to go through and see that you have a 2 log reduction when you double that 5 degrees to 10 degrees Fahrenheit. Here are a couple of examples. You can go through and you can see time in minutes. You can go through and you can measure what's the time and what's the temperature to go through and see, what's your reduction. Here we can go through and we can see the D value. D value is time in minutes to go through and have a 1 log reduction. Bacteria, to go through and see that, hey, we're at 10,000. Here we've dropped to 1,000. We'll go through and we see it was 1.5 minutes to go through and have that D value, to go through and have a 1 log reduction, or to go through and remove basically 10, a 90% reduction. It took D. If we look at Z value, we go through and we see, hey, what's the temperature required to go through and go from that 1 log reduction? To go from 30 to 3, that's a 1 log. That's a factor of 10, right? What is required to go from that factor of 10? We see that, well, hey, it took, 90 degrees Celsius at that to go through and reach 30. And then we go through and we see, hey, it takes 100 to go through and reach 3. So we can go through and we can see that that Z value is a factor of 10 degrees Celsius. Great websites to go through and give you some additional information to go through and look as far as reference limits. This one right here, as far as the North American Meat Foundation goes through and does process lethality spreadsheet. It's an Excel spreadsheet where you can go through and you can actually put in values for different products with different bacteria in mind, and it will help you calculate what the temperature has to be able to go through and make sure that you have a safe product. Great websites. Both of these go through and have the same thing, and it's one of those. The reason I put both of them on there is in case one of them is no longer working, they will both take you to basically the same starting point. Down here we have FDA guidelines as far as what's required. Okay, what is required? Chemical limits. Chemical hazards can be divided into those that are naturally occurring and those that you've caused. And so it's one of those of naturally occurring, may be one of those to where there may be levels of nitrite in the food. You can also go through and add sodium nitrite. Physical limits, we're going to go through and we're going to pick up here on the next 15 minutes. So we're going to go through and just wait and let this kind of time out, just so that we can go through and make sure that we don't mess up on the next slide.